Systems are often created to optimize for a specific outcome. The guiding assumption is simple: what gets measured gets managed. But this process of measurement can introduce dynamics that cause a system's behavior to drift away from its original intent. In this explainer, we'll examine the structure of that dynamic.
At the heart of this issue is a conflict between our assumption about measurement and what we often observe in reality. We assume that applying quantitative measurement to a process will improve it. The observation, though, is that the very act of measuring something can end up distorting the process it was meant to improve. So, to understand how this distortion happens, we first need to break the system down into its two fundamental components. There's the objective the system is actually trying to achieve, and then there's the tool it uses to measure its progress. The first component is the true goal. This is the system's intended purpose. It's almost always complex, multifaceted, and qualitative. And because of that complexity, the true goal is very difficult, sometimes even impossible, to capture in a single number. So, to make that complex goal manageable, systems rely on a proxy metric. This is a simplified quantitative number. You might know it as a performance indicator that's chosen to stand in for the true goal. It's selected precisely because, unlike the goal itself, it is easy to measure and track. In the beginning, the relationship between these two parts is usually healthy and aligned. The proxy metric does a decent job of representing the true goal. Any effort to improve the metric also tends to advance the overall goal. But then, a critical shift can occur. The proxy stops being just a simple indicator and instead becomes a target. This happens when real pressure is applied to the metric, when it gets tied to things like evaluations, funding, or other incentives. This is the point where the relationship starts to break down. This mechanism is described by an observation known as Goodhart's law. It simply states that once a measure becomes a target, it's no longer a good measure. The system's focus naturally shifts from achieving the complex goal to just hitting the number that's supposed to represent it. A related principle, Campbell's law, explains this a bit further. It points out that the more you use a quantitative metric for high-stakes decisions, the more pressure you create to corrupt that metric. The proxy gets transformed from a tool for monitoring into an object to be manipulated. Now, this divergence between the goal and the proxy doesn't happen overnight. It's a gradual process. As pressure is consistently applied to the proxy, the metric and the true goal slowly but surely drift apart. This is sometimes called the running down process of a metric. The process typically begins with a phase of positive learning. In this stage, actors in the system figure out how to genuinely improve performance. Their efforts to move the proxy metric forward also result in real progress toward the true goal. Everything is still aligned. But then, the system can enter a phase of perverse learning. Here, actors discover ways to improve the proxy metric directly without actually improving the true goal. This is what's often meant by gaming the system. At this point, hitting the number becomes disconnected from improving real-world performance. In the final phase, the system itself becomes distorted. The efforts to maximize the proxy metric now begin to actively harm the true goal. The very processes the metric was designed to track become corrupted, and chasing the target leads to outcomes that are the exact opposite of the system's original purpose. What's critical to understand is that this kind of system failure doesn't need a villain. It doesn't require any malicious intent or central coordination. It emerges naturally from the structure of the system itself as people make rational choices based on the incentives they're given. If we look at the individual level, the behavior is completely rational. Each person inside the system is simply responding to the incentives in front of them. Since success is being defined and rewarded by the proxy metric, it's only logical for them to focus their efforts on improving that specific number. But when all of these locally rational decisions are added up, they produce a globally irrational outcome. The system as a whole drifts farther and farther away from its original mission. By perfectly optimizing for the proxy, the system ultimately fails to achieve its true goal. This dynamic helps us resolve the contradiction we started with. The system isn't necessarily broken. It's working perfectly according to its own internal logic. It is successfully optimizing for the target it was assigned. This leads to what's known as the performance paradox. The performance paradox observes that this running down of metrics is a constant. As one measure gets gamed and distorted, it loses its connection to reality. So it has to be replaced by a new, different metric to reestablish that link to actual performance. This cycle of measure, erosion, and replacement becomes a core mechanism of how the system operates. The fundamental error in this entire dynamic is not the act of measuring things. The failure occurs when the system begins to confuse the measurement with the thing it is supposed to be measuring, when it mistakes the simple proxy for the complex goal it was created to represent.
Ultimately, this reveals a core principle for understanding any system. Regardless of its stated mission or its original intentions, the true purpose of a system is simply what it does. Its outputs and behaviors show you what it's actually optimized for.